Thank you all for joining us today. My name is Kevin Jones with DataPark. We're here to talk about a webinar introducing the idea of calculating maximum sustainable rate, or MSR, with DataPark. To start off, we've got a few housekeeping items that we'll talk about. So during the webinar, please feel free to answer or ask some questions. There's a box in the panel under the questions where you can type those in. Also, certainly happy to follow up with any questions you may have. We've got our email address up there, as well as our website. Look forward to hearing from you, and please take a look at the resources we have online. Let's go ahead and get started. I'm joined today with my colleague Ron Baldus. So Ron, you want to say a few words?
Ron Baldus with Capstone Technology. I'm the Chief Technical Officer. I've been working with MSR tools for many years. It's been a core of our tools that we offer.
Good. Well, thanks for joining, Ron. I know you've got years and years of experience working with plants and with DataPark as one of the original founders. So certainly looking forward to hearing this story. As an agenda, we'll start off with an introduction to the MSR. Go into this customer use case. I know I'm really excited about this one. You and I, first you were sharing this story, 6 months ago, and as you were telling that story from the customer, it's like, man, we need to find a way to share this with other people and get this story shared. So I'm really excited to hear you talk about the customer and their pain points and how we solve those and some of the steps, and then I'll open it up to some questions and answers. So I'll turn this over to you, Ron, and go from there.
Hey, okay, thanks. So the topic is MSR. It's been around for at least 40 years that I know of when I first was introduced to it. It seems like every year the production departments throughout a plant are asked to, how can we make more production for the next year? And they all scurry around and they try to put forth things that they can do, capital they can invest, and then they get back together, and it tends to be a bit of a disjointed effort and isn't consistently done between departments. So MSR, it's basically a framework for factual, meaning data-driven, and consistent estimates of process capability. We need a consistent way of looking across processes, and so we all talk the same language. So that's the goal of this. As we go through, we'll perhaps put some little new concepts in and use terms in a little different than what you're used to, and the idea is that we all get on the same page. So let's start with what's an MSR chart. Our goal is to find out what can a single process do, and then we apply this same technique across all the process units in a plant. So to do it for one processing unit, you take the production, you sort it, plot it from highest to lowest, that's the red line here, and then you use that to say, what's the maximum rate you can achieve? Well, you could say it's the top point here, but that never happens. You have some of them that can be 10%, 20% more production. But if you really want to hang your hat on what can you actually do, there's a maximum sustainable rate where you pick, typically people use 90%. At the 90% point from the beginning, and that's the point that you can have a sustainable rate. You're not going to try to pick the one-offs here or higher up. We can make this day in and day out. If everybody gets out of our way, this unit can run that fast. Then we calculate the average. That's simply the average over the 365 days. And average divided by MSR is a utilization. So we characterize every unit operation in the plant with what's its maximum sustainable rate and how close are we to that. And the goal is we're trying to make more production. So we need to take that part, the part that we haven't achieved, and break it into two parts. There's a slowdown part and there's a downtime part. In this case, the slowdown part was 12.7% and the downtime is 4.6%. So as we come up with ideas as how we're going to increase production, we have to address one or the other of these to get the utilization up. So you can get the utilization up by affecting those, or you can take the MSR up by doing a capital investment. So that's just it's simple to do. We've got a tool that will make the chart for you. You could build it by hand if you wanted, but for the speed's sake and consistency, we have Parkview has a tool to do that. So why use MSR? The goal is to increase the capacity of the entire plant, not just one unit operation. So we need to identify the capability of each one of the units. Here I'm showing 8 units, and I'm showing the utilization level and the MSR for this unit 3 that we'd say perhaps that's the slowest one in the plant. So we get the maximum rate and the utilization. Without using this technique, if you ask 3 people in the department, 3 different answers will come forth. You'll get, it's amazing the range of what they believe they can do. You'll get one, well, oh yeah, well, on my grandson's birthday 3 years ago, I know I came in at work and I ran, over here, I ran 40, so the rate's 40. And we just can't have those kind of guesses. We need to back it up with data, and the MSR chart provides that basis that each unit operation's evaluated the same way. So when we look at the utilization portion of it, how can we move the red bar up? We have slowdowns and we have shutdown. Slowdowns, there's 4 possibilities. You have inventories low upstream, the people who are feeding you a feedstock, there isn't any, so you got to slow down. Or the people downstream from you that you're providing feedstock can't take it away, they're full up, and so you have to slow down. Or the utilities, the steam plant, the electrical, the delivery system, whatever, has problems getting resources you need. Those 3, you really can't do anything about yourself. If you're trying to look at your process, the only one you can do anything about is if you have process problems. So under the slowdowns, we try to identify all the process problems you're having that's preventing you from getting that portion of the utilization. Then on the downtime, there's 2 major types of downtime. There's planned and there's unplanned. And then the unplanned downtime, it's either another unit got you or you're responsible for that downtime. Split between the 2. Again, the first 3 here, there's nothing you can do about those. That has to be under their purveyance. But you can take the downtimes that you're experiencing and seeing through either preventive maintenance measures or something if you can reduce your downtime. And that's to try to move the green one up. So to take a look at how we go about doing that, what do we need to do the MSR analysis? We need the process unit production data for a year. We need somebody who knows something about the process, subject matter expert, because when you start digging in and saying, what can we do to move those up? It needs to really be somebody who knows the process. If we're lucky, the plant will be recording reasons for slowdown and downtime, and we can use Pareto charts to organize those from top to bottom of what's the most important, what can we go after. And then you need tools that can do the identification of the downtime, help you find it, and you need tools to make sure that it's sustainable. If you do move the bar, we need to be able it stays there. We can't just do something and walk away. It's not going to stay there. So what do you do with MSR data across multiple units? What you do is you find the limiting production, and I'm going to say it's unit 3 here, although the next 2 are unit 5 and unit 1, are also on the low side, but unit 3 is what we're going to deal with. And we need to find out, like I said before, what is causing low utilization? Is it slowdown? Is it downtime? And what are those components? We're trying to move the red bar up on that one. But you can take another tack and you need to ask, can the MSR be moved up? And that's a whole different approach that says, and you do them both, but can we spend capital? What can we do to take a physical limitation, spend money, and get that particular unit operation to run faster? So work on utilization and then work on moving the MSR. And here's a gotcha. Well, sometimes we spend so much focus on one process unit that everybody's sure is the only thing standing in our way. You can spend a chunk of money to get the rate up, and all of a sudden they turn around and look, and another unit may not be far behind. Like these three utilizations are low because they can't be much higher average than what the lowest average is. They can't run faster. There's no place to put it. So when you move this up, either through MSR or utilization, it doesn't necessarily mean the others' utilizations will move up. So you need to look at the next in line for who's going to cause your problems, or you're a real surprise. You spend a chunk of money, you think you're going to get a production increase of 10 and you only get 5. Well, now you got to spend a chunk of money more. So the payout may not be what you think. So you got to look at all process units in the system. So let's look at a MSR client use case. The easiest way is, let's just show you a typical case. This is a paper mill, and the same question, they want to quantify what are the production bottlenecks in their system. That identify the bottleneck, identify a solution, implement the changes, and then sustain the benefits. So it's not just let's go out and find out what's wrong. We got to go, or not, what the limits are. We got to come up with a solution for how to solve that to get more production. The data park tools that we utilize to do this are data connectivity and transformation. The data connectivity is we need to be able to get data from any historian that's out there. I don't care whether it's a SQL server, whether it's a real-time historian, we need to be able to have access to the data, quality data. And then there's data aggregation, and this people don't think of very much, but in these evaluations, we look at data over years. We're not looking at data over minutes or hours or days. We're looking at whole years worth of data. So if we're in troubleshooting and trying to correlate things and look at them, we need to have access to data kind of at the speed of thought. If you're chasing an idea down the road and all of a sudden you hit it and you wait 20 minutes to get data back, it's not conducive to solving the problem. So part of Data Park is a data aggregation step where we do hour and day averages, and it allows us to look at the data much faster. And you'll probably see a little bit of this in the response to the data when I'm going through examples in a bit. And then we have analysis tools. We've got an Excel add-in, and that does the data mining, extract the data out, and generates the MSR chart. We use trend capability in Data Park to identify and find issues and then troubleshoot it. What can we do about that? Is there anything obvious? And then Pareto for if we have downtime reasons, like a reason tree that people have been putting reasons against, we can make a Pareto diagram to organize the things that are causing downtime from highest to lowest, and look if we can change that distribution. So the MSR steps that I'm going to go through the demo, four parts of it, basically. We have a data normalized sheet that's Excel that we pull production data into for each unit. Then I put the tag in for each unit. We enter the time span, and we generally do a year. And the reason we do a year, it doesn't necessarily have to be, but many processes we work with have seasonal impact. So you need to get enough data that you get a complete cycle in there that's representative. If you don't have seasonal data, then you simply need to identify a period that you say is representative of normal operation and the distribution of your ups and downs. So we pick a year. And then you do add the production tags to the Excel sheet. And then we're going to get the data and select an MSR our option under charts to create the display. So this is one of the processes that a limiter. This or can be a limiter. This, what you're seeing right now, is the main unit. It's well documented, well instrumented and everything. Then over on the right, we're looking at a backup unit. We got to look at both of them because they're both doing the same thing in parallel. So we're going to get the tag for the backup unit. There's only one. It's all panel mounted controllers, nothing in the DCS. It's an old unit. So we're going to get that tag, and then we're going to go down, and first we're going to say we need daily averages. We're going to right click and go up to time type and say day, because we don't want to slow down for real-time data. And to do 5 years, we're going to go back and look at 2018, and we're going to put in 2,200 days. There's 2,200 days of data for that. And you can see why on the 2018 is on the left. There's about 5 years here. And they said the 2018 on the left because that was one of the best years they had. And they really have, because of market conditions and the like, they haven't necessarily run up to that speed. So we need to look at that. And then we are dragging the tag over from the second unit of operation, the main one, and adding that to the display. And I'm going to rearrange it here to 1250. Now, I like the trending at first. I just want to get a visual. Is there anything wrong with the data? Does it look like the tag's gone bad? So that's just what I do before I actually go to the Excel sheet. Now we're on the Excel sheet, and there's a data park add-in that you'll see. And if you click it, there's an option to do a data normalized sheet, and it adds the sheet you see there. That's the data normalized. And I've put in the dates from January 1st, 2018 to January 1st, 2019. And then I'm going to pick the time type to be days. We don't want minute data for that much time. Now I'm going to drag the tags over. Those are the two production tags I got off of the graphics display. I'm going to drag that tag is the sort of backup unit, the old unit. And then this tag is actually a calculated tag that's summing two flows for the main unit. And then we're going to get the data for the year, and we get 365 days of data. Now we've got to generate the MSR chart. You click the column that you want to generate it for. You go up to the button, you pick the MSR, and it's asking you to enter the percent that you want to use. And we're going to put 90% in. And that generates the MSR chart for you. So I'm going to drag it down over here where I can copy it. I'm going to copy it there. And then I'm going to do the same thing for the other one. I take the second column, take the charts, generate the MSR, put in 90%, say OK, and drag that MSR. I can copy it it's by itself, copy it, and I'm going to paste it elsewhere. So that's, we need to generate the charts for all unit operations in the plant. And then here we put them on the same page so we can review them. But the two we're going to follow up now on are the two that we just did. That's these two right here. And we're going to say how we look at that unit operation. So here are the two charts. This is the main unit. Its utilization is 83%. It's got an MSR of 1043. And then there's the sort of, I don't know if you want to call it a backup unit or failover unit, and it's running a utilization of about 35%. So something that sort of changed, we didn't anticipate this because we weren't aware of the second unit. The current way they're running, they hardly ever run this. It is periodically, or maybe every month or two, they'll run it. But when they're really up to rate, that's why we went back to 2018. Wait a minute, we can't ignore this. It's not just kind of sitting at the side. They were actually using it. And it accounts for, that 35% accounts for about 16% of the production of these units here. So what do we do now? You could say, let's drop this. He's not a limitation. We'll keep running the DSET here, the old one, and it's got plenty of production. But that's not what we do when you go into an operation ideas. You want to eliminate equipment. You don't want to there ends up being used as a crutch if you're not careful, which in this case is a little bit what happened. So we're going to take this on and say, we're going to get rid of this unit. And now we need to make the main unit run fast enough to take care of that. It's a bit of a tall task. So one of the things that we need to do, we're going to break down this utilization here into things we can identify that we think the problem is. And this downtime, I would like to split. First off, I'd like to know, is there anything we can do to the downtime? That 4.6%, there might be some opportunity there, but I need to know what the planned downtime is, because there's nothing I can do about that. So we're going to go back to our display here of the trend on the left over there, and we're going to take a look. And they said the downtime was about in, I think it was October or November. So let's get rid of the old unit. Just look at the main unit. So that's about October, I think. Let's zoom in on that, and we're going to figure out how many days they were down. So I zoomed in on it. It's daily average. I'm going to right click and go to time type of hour because I want a little more resolution on it. And then I'm going to find out how much time they were down. It's the gap between there. So I'm going to highlight that. And in Parkview, if you highlight the trend and you drag it down at the bottom, it gives you about how much time that span is. If you look down, it's about 9 days, a little over 9 days. So of the downtime that we have, the 4.6%, we just proved to ourselves that the downtime is 9 days. So I'm going to go back here and put those back up to the year data in case we need it later. So let's put this, we're just going to sequentially show how we step through the problem. So the downtime on the main unit was 4.6%. We went in and looked back and saw that it was down for 9 days, which is 2.5% of plan down. There's really nothing we can do about the plan down. That's somebody else's decision because it's generally a full plant down. They're doing it for other reasons. So we've only got, what do we have, 2.1% downtime that we might be able to do something with. And there's no way that 2.1% downtime is totally the responsibility of this unit. There's 8 other units in the plant, 7 that if one of those goes down, it could take it down. So there's 2.1%, and there's probably 1% of that. I doubt it's even 1 that's responsible to this one. So what I'm trying to do is come out. I've got a column over here. Where am I going to get capacity to balance this out, where we cover the shutdown of the old unit, and we need more capacity to move forward since we're going to be the limiting factor. So then we go to the next, the utilization. We're talked about downtime. We're saying we can't get anything from that. We go to the main unit, and our old unit's going to shut down, so we're not going to pay any attention to him, other than we lose 16% capacity. So the main unit, we've got a utilization of about 83%. And this is where an SME, subject matter expert, comes in that has experience with lots of these units across the country, and that should be 92%. And there's nothing unique about their setup that it can't be 92%, but it's 83%. We've lost 9% production, and the question is why is it so low? Even if we get the 9%, we're going to be 7% short. So we're going to, like I said earlier, we're going to go after the MSR. But first, we got to make sure we can get that 9% back. So we're going to go to back to the trend of the 2 tags. And we're going to take a look. You see in the green, that's the main unit. See how he's low in there? I'm going to try to figure out why is he operating low? Is he having a problem or what's going on? And if you blow him up and take a look, we've got the blue one's the old unit and the green one's the normal, the main unit. So what we want to know is, at the time it's low, if you take a look right in there, you see the green unit's low, that's the main unit. When they shut down the old unit, the main unit can pop up and run fine. So all those turndowns, all those slowdowns, it's not that the unit's having a problem at all. It's that they kind of just base load the the old unit, it's old. They don't have hardly any controls over it. So they just base load it. So just to check this out, I'm going to go put the gas pedal on. The gas pedal is the pressure on the main unit. Let's see what the gas pedal was doing. Well, they weren't even running at full. Normally these guys run flat out. And you can see when the old unit went down, they just put the gas pedal down, and the main unit ran faster. So this 9% down didn't have anything to do. Just time after time, you can go through this and look at it. This didn't have anything to do with the reduction. It wasn't his inability to do process the make product. It was that he was taking all the swings and letting the old unit run fairly base loaded. So we can get the 9% from an SME point of view, and from looking at the data, where that's not going to be a problem. Shut down the old one, lose 16%, get 9%, we're 7% short. So we have to go up to the MSR. And this is where, if you have a backup unit or a unit that you can just kick on anytime you want, you tend to not, it's easy to not invest in maintenance on either of the units because you can swing back and forth. And the main unit, the big one, had a problem, and it had been around for years. I look back, I think I had 12, 14 years of data, and it's been sick for that long. And one particular part of the process is sick. And it would require maintenance money to go after it. Well, who's going to spend maintenance money if you can just turn on this old unit? Although now you're having to keep repairs on the old unit, it just kind of gets lost in the shuffle, little repairs here and there, and you got to maintain it. So we, as an SME, we looked at the issue that they were having, the part that was broken, and said, what could we do if that was fixed? Well, hey, we can get 17% capacity is the belief. And then we were able to run some tests around it just to validate what was really happening, and did that fit with what our thinking was, and it did. So we sort of put your heart on the line and say you're going to get 17% capacity if you fix that. And overall, then we're going to get 10% capacity. So if you fix this issue and you shut down the old unit, so you actually pick up the utilization of the main unit, we're going to end up actually 10% more capacity. So the steps, what do you got to do? Well, you're going to move the MSR. We're going to spend maintenance capital. It's about $1 million a year, million plus, to do that. And we're going to shut down the old unit. At least we're going to not put any more maintenance money into it and leave it offline. And then those are two things to fix the problem. And then we have the sustainability issue where we said you can go from 83 to 90%. You can do that, but they're not used to doing that on this particular unit. So sometimes it takes some rethinking about how you approach problems and be proactive. So we need some sustainability help here to make sure that it stays there. So how do we do the sustainability? We do real-time monitoring with DataPark in a couple ways. One of them is you make a graphic, a process flow graphic that has everything on that processing unit on it. You don't have 4 or 5 screens where you're bouncing between screens trying to see what's going on. If you're troubleshooting or trying to teach somebody, you need to have one-stop shop where you go look at it. So part of what we do is we make sure we have these unit operation screens built for troubleshooting. And we tend to have a screen of trends. Sometimes it takes 2 screens of trends, but if we can get it all on one, and most unit operations we can, all the key things, then in one place you can see if you're having a problem. You see all the tags. Otherwise, the tendency is let's grab a tag here, grab a tag there. Add a 3rd tag, add a 4th tag. That works, okay, but you sometimes miss something else that's going on, where if you look at all the trends at the same time, down in the corner, how come this is oscillating? Or hey, every time we go down, something happens in another part of the display. So those are combination. We got to get it in front of people, and we got to have one place that we communicate between operators and managers and supervisors, where we're all have the same view of what's going on. And then typical to what people do, of course, you're going to have daily reporting of KPIs. That's always a fundamental part of sustaining benefits. And then notifications. I'm not a big notification guy, but when there's a problem that you say, when I see this happen, we need to know now, because we've only got 6 hours or 2 days to do something to keep from going down. So we try to be proactive with the notifications. And then downtime tracking. Every unit operation, and if you do downtime tracking at the end of the year or any period of time, you can look at the previous year and go, what's eating our lunch on downtime? And you pop it up, it has a reason tree where they put in downtime, and you can generate a Pareto diagram without doing any work, without going back to the data to see what the downtime issues are. So what's the outcome of this and the results from a customer perspective? Their benefits were identified and implemented for $1.1 million was the investment. We got an incremental capacity of 10%. Actually, I think it's about like 12 or 13%, but we achieved what we said we were going after. The old unit is down. Now we got to make sure it stays down, and that's where the sustainability, we got to make sure that happens. We reduced the steam by 15%. That was, we're after production, but by fixing the unit for many years, I mean, they were paying a large steam penalty, and the steam penalty was actually $1.6 million per year. So without requiring the capacity increase to pay for this, just the energy savings alone paid for the fix. Operational flexibility. Now that we have capacity, it may be that from the other units balancing around here, that we'll only get 5% of that capacity that we need. We can increase the production in the facility 5% over what it was in 2018, which is one of their best years. So we may have some flexibility in that to use that capacity in another way. If an upstream or downstream unit from us is having problems, we may be able to relax the requirements of the feedstock or increase the requirements of the product stock downstream if that helps them make more production. So we have the ability to maybe help some other people solve their problems. So on the sustain side, we're monitoring with graphics and trending. The graphics, we continue to build in all the logic in the graphics for things that they touch on a day-to-day basis that might affect the operation, and the trending tools that I discussed. We want to keep the unit tuned, and we want to be proactive about problem solving. We got to maintain that sustainability that we said we can get. That's key. We got moved the MSR a lot, but now we got to keep that sustainability. And because of this monitoring graphics, training is a real improvement in 2 ways. One is they don't have to train on the old unit anymore. So that's kind of your training for each one of those units. So we're training on one unit, and then with the graphics, with everything on one graphic for a new operator, new engineer, they can pop on that, and it's a very short time for them to learn what the process is doing by having it all on one screen. So from a customer's perspective, this part of the MSR turned out much better than we actually thought possible because of the steam savings and being able to not have to operate the down unit. So that's MSR from beginning implementation and follow-up. Are there any questions?
Well, first, Ron, I just want to thank you for sharing the story. That was great. Like I said, when you first told me the story 6 months ago or so, it sounded like a good one, and it seems like you guys had some fun with this project. Is that right?
Yeah. When you can help somebody and everything goes the right direction, and you'd make the process simpler rather than more complicated, it doesn't always work out that way.
Yeah. One question I had, it looked like there's quite a few iterations as you were interrogating the data, and you needed that data to come back at the speed of thought. It probably didn't work out just the first time. Can you speak to some of the main challenges that you faced in that iterative process?
Well, that's a good question. Well, one, we were surprised when we started down the path was that we had 2 units to think of. And it's never clear till afterwards. Like hindsight, you'd say, well, duh, we should have known that was probably happening between the 2 units. But you tend to chase a few things down the road before you kind of cue in on the problem. So it isn't, we make it look like it was one easy step. It wasn't much different than that. But you chase a couple other things to how come the process is having a problem, and then it just kind of coalesces and you see, well, the truth of the matter is pretty simple.
Kind of on that same theme, what went easier than anyone expected?
What went easier? Well, it's always fun when you get the response times on the data. It hurts so much if you can't get that data when you need it. Like if you took a look at the screens, I'm always really pleased with how well the data response is. And if you notice, remember we went the 2,200 days on the production. I mean, how can you beat that? You can go, if we didn't have that, I would bet just getting those 2 tags back would take probably 15 minutes or something like that. You can't go back, especially we want high density data. And if you want high density data, it really, for right now troubleshooting, then that hurts you on the long term. So I'm always really pleased with how that works out for us.
And what about some of the people you were working with? Were there any comments that they shared while you were going through this process?
I think you get throw out quite a few ideas about, well, they sort of lose track. I think they knew the set was sick, but they didn't realize what was really bothering, how bad it was bothering them. That was a eye opener, I think. How could we kind of let this go? I think. Well, they know why to let it go. They don't have any capital. They're not a large facility, but it brings it home to them that I think there is a reason for chasing these. You go after them, they pay for themselves. If you structure it right, it will pay for itself. And I think I don't think they realized that at the time.
Good. And just, you mentioned the sustainability, and to me, that's always, the crucial step, right? It's easy to make these improvements once, but then you've got to be able to sustain it over the long run to really, make our customers money. Can you speak to how that's been going the last few months?
Well, it's really early on. I think we've only did it like 2 months ago. So being able to, and they're not necessarily in a full production position yet from a market point of view, with market conditions the way they are. So it hasn't been pushed to where we can prove the sustainability yet. Everything looks good. We've not used the other unit for a couple months, but we've got to wait and see. And that's where you've got a problem, because all of a sudden people get lax. You got to be really on top of every little thing. Just because you have a little more capacity than you need right now, that doesn't mean you can let any of it go. So that's going to be, so far it's okay, but we really haven't ingrained that yet.
And the last question I have, Ron, just, people who are listening to this today, might be considering an MSR initiative. Any advice or words of wisdom you could pass to them?
Yeah, well, just follow the process. It's not complicated to do an MSR, and especially if you're using our tools. And you need to split it up into those. Be methodical and split it up into those zones, and then try to break the subzones up as much as you can. In our case, we didn't need to, because the sustainability wasn't an issue with the main unit. But those are a little harder to chase down, and that's where the trending. We showed you doing some simple trending things, and we came up with conclusions. But the multi-trend one, get all the tags on one. I don't think we tend to do one tag at a time, looking at things, and when you put them all on one and you start using that, I think that's the really important one that they need to pay attention to.
Yeah, and then it seems having the plan for that sustainability piece too, going into it, that that your work's not just done.
And that's one that people do not address, I think. And then ourselves, it's real easy to go, voila, we did good, and you walk away, and then you're surprised, half your benefits gone, a year or two later if you don't go after it.
Yeah, good.
Thank you again, Ron. It's certainly great hearing the story and sharing your insight. And thank you to all of us who joined us today. We're going to wrap it up from here. If we didn't get to any questions that you had asked, we will get to those over email. So please, if you've got an extra second, feel free to type those in, and we'll get to those as soon as we can. And we're always looking to hear from you, our customers, and hear your stories. And if you're willing to share those stories with others on the learnings and the experiences, please let us know. We'd like to feature you in a future Solution Spotlight. Just send us an email to dp-info@datapark.com. Thanks again.